All right, number 11. Car A is traveling on a straight east-west road in a westerly direction at 60 kilometers per hour. Car B is traveling on a straight north-south road in a northerly direction at 70. The roads intersect at O when car A is X kilometers east of O and car B is Y kilometers south. The distance is Z. Find the rate of change of Z. So we need dz dt. When car A, so when X is 0.8 and car B is 0.6. And we know dx dt is negative 60 because that distance is getting smaller, and we know dy dt is negative 70 because that distance is getting smaller. We know the relationship between x, y, and z is Pythagoras. X squared plus y squared equals z squared. So differentiating, we've got 2x dx dt plus 2y dy dt equals 2z dz dt. And then we just substitute in the values. So we're going to have 2 times 0.8 times negative 60 plus 2 times 0.6 times negative 70 equals 2 times, we need to figure out z because we need to find out dz dt. So if we use Pythagoras here, so we're going to have 0.8 squared plus 0.6 squared equals z squared. So z is going to be 1. So this goes here. And when we solve this, so we have that dz dt is negative 90, which makes sense because as this distance gets smaller, so is z. All right, so that's for A. B, if we have the same question, but car A is traveling this way, that means that dx dt is positive. So we're going to have still 2 times 0.8, but times positive 60. So everything else stays the same. And when we solve this, we get that dz dt is 6. And these are both in kilometers because this is, oh no, this is kilometers per hour. So kilometers per hour. All right, so number 12, we've got the volume of a solid is given by that. So that's a sphere and a cylinder. At the time when the radius is 3, the volume is 81 pi, and the radius is changing 2 centimeters per minute, and the volume is changing at a rate of 204 pi. Find the rate of change of the height at this time. Okay, so if we differentiate, we have dv dt equals 4 pi r squared dr dt plus, now we have product rule. So we're going to have first times the derivative of the second plus the derivative of the first times the second, and then we fill in our values. So we have 204 pi equals 4 pi 3 squared times 2 plus pi 3 squared times what we're solving for plus 2 pi 3 2. And now we need to solve for h. So using this, we're going to have 81 pi equals 4 over 3 pi 3 cubed plus pi 3 squared h. So pi can be canceled. because it's in every term. And then we have 81 equals, oh, also this can cancel. So we have 9 times 4, 36 plus 9h. And then we can divide everything by 9. So 9, 4, and h. So h is 5, which goes here. And then again, we can cancel pi because it's in every term. So we have 204. And we've got 9 times 8, which is 72, plus 9 dh dt, plus 4 times 15, 60. So we're going to have 204 equals 132 plus 9 dh dt. And when we subtract 132, we're going to have 272 equals 9 dh dt. So dh dt divided by 9 is 8, and that's in centimeters per minute. All right, number 13, a man is standing near a street lamp casting a shadow. The street lamp is 15 meters tall. The man is 1.8 meters tall. The man is walking away from the street lamp at a rate of 0.5 meters per second. So let's say dx dt, and it's getting larger. I'll come back to that. So it's 0.5. So when he's 10 meters away, so this is 10, or that's x, because that will be 10. So this is positive because that distance is getting larger. And, this is the length of his shadow right here. Okay, so if we want this, we are going to have, let's just set it up like this. So we're going to have similar triangles. So we have the larger triangle here. This is x plus s, and this is 15. And we're going to have the smaller triangle, which is s and 1.8. So we're going to have 15 is to 1.8 as x plus s is to s. So we'll deal with that in a second. So the, so we have 15s equals 1.8x plus 1.8s. So when we subtract 1.8, that's going to be 13.2s is 1.8x. So when we differentiate this, we're going to have 13.2 ds dt equals 1.8 dx dt. So it wants the length of the shadow. So we want s when x is 10. So we're going to have 13.2 s equals 1.8 times 10, which is 18. And when we do 18 divided by 13.2, we get 1.36. So that should be how long his shadow is. So now we want how fast the length of the man's shadow is increasing. So this one we want ds dt. So now we're going to have 13.2 ds dt equals 1.8 times 0.5, because that's dx dt. So that ends up being ds dt ends up being 0.0682, and that's meters per second. The speed of the tip of the shadow. So we want the speed of that, the rate of change of that. So we want dx plus s with respect to t. So we know this length on the bottom equals to x plus s. So the rate of change of that is going to be dx dt plus ds dt. So we're going to have dx dt is 0.5 plus what we just found. And that is going to be, that's 0.5682 meters per second. Okay, the particle P moves on the curve y equals sine x so that its x coordinate increases. Okay, so we have dx dt is 2. Point A has the coordinates 3, 2. When the x coordinate of P is x, so that's going to be the point x sine x. The angle AP makes an angle of theta with the positive x-axis. So if we have this horizontal line, this is theta. Okay, so explain why tangent. All right, so let's make a triangle. So we have tangent theta equals opposite. So we want this length here. So if that's x, actually let's use a different variable. Let's say this is y. So if we want y, this is going to be, so this whole thing is 2. And then this little bit is going to be sine x. Okay, so y is going to be 2 minus sine x. That opposite from that angle. Over the adjacent, which is going to be 3 minus x. Because if x is like -4 here, this whole distance is 7. So 3 minus -4 is 7. Okay. So that is the same. So if we factored out a negative, it'd be sine x minus 2. And negative down here, x minus 3. So yeah, we get A. All right, so for B, find in radians per second the rate of change of theta with respect to time at the instant when P is at the origin. So we want d theta dt at 0, 0. So we have tangent theta, so the derivative of tangent theta, secant squared theta, d theta dt, equals, so now we need quotient rule. So we're going to have x minus 3 squared on the bottom and start with x minus 3 up top. And then we have times the derivative of u, which is going to be cosine x, and then dx dt. And then minus u times the derivative of v, which is dx dt. And then we can fill in some values. So we're going to have, so remember it's at 0, 0, so we've got 0 minus 3. Cosine 0 is 1. Dx dt is 2. Sine 0 is 0, so -2 times dx dt, which is 2. And then 0 minus 3 squared is 9. So we need secant theta at 0, 0. Okay, so we have that tangent theta at 0, 0 is 2 minus sine 0, which is 0, over 3 minus 0. Okay, so then we're going to have the relationship, because it's without calculator, you have to find the relationship between tangent and secant squared. So that's 1 plus tangent squared is, secant squared. So we're going to have 1 plus 2/3 squared, which is 1 plus 4/9, which is 13/9 is secant squared. Okay, so here is 13/9. So now we're going to cross multiply by 9/13. And this is -6 plus 4 over 9. So this is -2/13. And that's radians per minute second. Okay. 15. The diagram below shows two particles, x and y, on a horizontal plane containing a fixed origin O. At some instant, OX is 30, OY is 50, so we'll call this x, this y. So x is 30, y is 50, and theta is 60 degrees. At the same instant, x is moving in the direction OX. So we have dx dt is 20, and y is moving, dy dt is going to be 10 to the -1. So no, it's not. I looked in the the answers, and it's -10. So this is -10. Find at the same instant the rate at which the distance xy is changing. So we want dz dt, assuming the angle remains constant. So that's just like this is going out and this is going out. So just dz dt is changing. So we have the relationship here is going to be z squared equals x squared plus y squared minus 2xy cosine theta. And theta is constant, so you don't have to differentiate with respect to theta with respect to time. Okay, so we are going to differentiate this. So we're going to have 2z dz dt equals 2x dx dt plus 2y dy dt minus 2 cosine theta, and now the derivative of x times y. So we're going to have first times the derivative of the second plus the derivative of the first times the second. Okay, so now let's fill stuff in. We need to find z. So x 30 squared plus y, which is 50 squared, minus 2 times x times y cosine 60 degrees. And cosine 60 degrees is 1/2, so this will cancel with that. So we're going to have 900 plus 2500 minus 1500. So that's going to be 1900. So z is square root 1900. All right, so we're going to have 2 times square root 1900. dz dt is what we're looking for. 2 times 30 times 20. Just substituting stuff in. 2 times 50 times -10 minus 2 cosine 60. And then we have x times -10 plus 20 times 50. So if we simplify this a bit, we can cancel 2's because 2 is in every term. So this here is square root 19 times 100. So we can take the square root of 100, leave the 19 under there, dz dt. And then we're going to have 600 minus 500. And then we have, that's minus a half. And then we have negative 300 plus 1,000, which is 700. So this is going to be 100 minus 350, which is negative 250. And then we can divide by 10. So that's negative 25 over square root of 19 dz dt. So this is about negative 5.74, and this is going to be in meters per second. Okay, so now B, assuming instead that theta is decreasing at a rate of 1.5. So now we have d theta dt is negative 1/5, negative 1/5. So we have to differentiate this again, but now theta is a variable. So we've got 2z dz dt equals 2x dx dt plus 2y dy dt. And then we're going to have minus 2. Well, here, we'll just do plus. So now we're going to have, so if we make u x, y, and v is cosine theta, negative 2xy. So du is the first times the derivative of the second plus the derivative of the first times the second, and dv is negative sine theta d theta dt. So now we're going to have plus u times dv, which is negative, so we positive, sine theta d theta dt, plus cosine theta times negative 2x dy dt plus negative 2 y dx dt. And now we have to fill all this stuff in. So 2 times root 1900 dz dt is what we're looking for again, equals 2 times 30 times 20 plus 2 times 50 times negative 10 plus 2 times 30 times 50, I'm here, sine 60, d theta dt is negative 1/5, plus cosine 60, negative 2x is 30, dy dt is negative 10, plus negative 2, y is 50, dx dt is 20. Okay, so now we can cancel some things, hopefully. So we have the 2's can go away. Like this 2. Okay, if we factored that 2 out. Then we will have, so remember this is 10 root 19. So 10 root 19, dz dt equals, now that's 600 minus 500. And then sine 60 is root 3 over 2. So we have, okay, wait. So this is minus, first of all. 50 and 5 cancel to be 10. So that's minus 300 root 3 over 2, which I'll write as 150 root 3 actually. Okay, and then we have cosine 60, which is half. And then we have negative 300. Nope, positive 300 because of the negative 2. And then we have minus 1,000. And then we can write that, so that's negative 700 over 2, which is negative 350. So negative 350. Now we can cancel some 10s. So 10, 10, 10, 10, and 10. So we're going to have root 19 dz dt equals 60 minus 50 is 10 minus 35, which is negative 25, minus 15 root 3. And then we're going to divide by that negative square root 19, which is about negative 11.7, and that's meters per second.